I don't have a way to get yours in here.
Seats in here for you?
Huh?
Are we running out of seats?
Well, there's some empty ones, yeah.
Some of our classes coming out.
Yeah, I think they're okay.
It's good we got a lot of speakers. That's really nice.
Seriously?
Is that on this?
Yeah.
We have it. Let's display it.
Let me go.
I mean, I could.
That's crazy. He's got a PhD, right? Yeah.
First weather watch in a while.
I'm so excited.
Wi-Fi here is not working, so I'm using this on my phone.
Oh, okay, welcome everyone to our Weather Watch discussion. For those of you that aren't familiar with this, for those of you that are familiar with this or unfamiliar with this, this is our department's, it's gone on for decades, discussion of the past week's weather, current weather, and future weather, as well as discussions of short-term seasonal or climate-type impacts that have been observed. Everyone is encouraged to participate, ask questions, give a short presentation on something that happened that's really interesting to you. This semester I'll be leading many of the discussions, but I expect that perhaps some of my own students, as well as students in 452 and 751 might, near the end of the semester, step up and lead these discussions. We also have some undergraduates from 141, the weather hazards course that Professor Tripoli is teaching, that will be also joining us. One of the things that we have to get figured out, because it might have been different in the timetables for these different courses, is the starting time for this. Historically, this used to begin at 12:15 and run into about 1 or 1:15. In the last year, it's been kind of gradually moved to noon, and I'm unsure what the students in the other classes were, how it was communicated to them, so we have to find the optimal time so everyone can possibly participate. So again, what I'm going to start off with today is a brief discussion and just an overview of some of the climate, the features over the last season. This is a look at the 500 millibar geopotential heights. I don't have the climatology on here, but the 500 millibar or hectopascal geopotential heights in the fill pattern here, and the so-called anomalies, the deviation from a long-term climatology, typically a 30-year climatology. So this is the average geopotential heights from June through the end of August, so 1st of June to the end of August, which is climatologically, or in the meteorologically speaking, our summer period. And a couple of the most conspicuous anomalies, that is deviations from the average, is this region of higher heights that's been observed over, these are in decimeters, over the Pacific Northwest, extending out into the North Central Pacific and off the east coast of the United States. Now typically higher heights are going to be associated with, at the surface, with generally perhaps drier conditions, significant warmth. And we know that if you recall back in late June and early July, there was that big heat wave over the Pacific Northwest. And I have some suggestions that one period, that period in late June, early July, actually contributed a lot to this big anomaly that you see sitting off the west coast. Most of the rest of the summer, this was a little bit more closer to normal in terms of geopotential heights. If you look at the overall average geopotential height, you can see a bit of a trough over the central part of the United States and the eastern United States. And the weather conditions that are experienced here generally were, obviously periods of significant warmth, but wet along the east coast of the United States, from New York State, in New England, and parts of Pennsylvania, and sort of moderate conditions, I would say, over us in Wisconsin. But we'll look more carefully at that and look at the precipitation deficits that we've accrued over this period. If they go to 250 hectopascal heights, you can see a very similar sort of pattern. You can see the trough here, this ridge axis being a little bit shifted over Montana, but again, the anomalous heights continued right over the Pacific Northwest in this 90-day average for the so-called summer season. If we expand this view, weather isn't just over North America, it's obviously global, and these are all again taken from the GFS final analysis, so this is not using the reanalysis data. You know, very interesting pattern that I haven't had an opportunity to really look at in depth of anomalous heights are just ringing the northern hemisphere, higher heights ringing the northern hemisphere with near the poles a little bit lower geopotential heights. This is again 500 hectopascal, but kind of really interesting pattern, which would suggest that maybe a shift in the jet a little bit toward higher latitudes during the course of this particular summer. And this is just the 30-day geopotential height from over the last 30 days. And just to show you that those anomalously high heights that we saw over the Pacific Northwest have now been replaced with conditions that are closer to normal. But you can infer from this a shift in some of the patterns of the mid and upper tropospheric jet pattern. You can see over the Atlantic, just east of Greenland, higher heights, sort of a high over low type of pattern, this dipole type pattern, which is associated perhaps with some sort of blocking structure at 500 hectopascal. And then again, you can see this band of really high heights that extend from the east coast of Asia across most of the Central Pacific. So really interesting pattern. And then again, this may be another dipole of the heights that may indicate some sort of smaller scale blocking light feature over the last 30 days ending yesterday. So interesting flow anomalies. We'll look at these over the course of the season just to get some sense of how they've developed. What are the consequences? What's happened down at the surface? So this is the current from yesterday, a couple days ago actually. Yesterday it was released. This is the U.S. Drought Monitor Index. And as you've perhaps heard, over much of the western United States, they've had a really exceptionally strong drought. Extreme to exceptionally strong drought conditions exist over the western part of the United States. And even closer to home, you can see in southern Wisconsin, we're experiencing, and have been experiencing for most of the late spring through the summer, a moderate drought. And so we're going to look into the forecast coming up to see how that's going to perhaps maybe changing over time. Over much of the eastern United States, there are kind of no significant drought concerns at this point. And again, because of some landfalling tropical cyclones over the southeastern United States and the Gulf of Mexico, and their track up to the northeast, we can see that in parts of certainly New England and New York State and Mid-Atlantic, no drought conditions whatsoever in those regions. And again, if you have questions, please jump in. Closer to home, this is from the Milwaukee forecast office. Again, talking about the very dry conditions that have continued over the past 30 days. This is the accumulated precipitation over Wisconsin. See the outline of the state here. Over the southern part of the state, Dane County, Rock County, was looking at only 1 to 3 inches of rain over this region. But to the north in this band, from Stevens Point over to Manitowoc, you can see 5 to 6 inches of rain have occurred, and then drier conditions further to the north. Again, this is that drought area, and so again, not getting significant precipitation is going to certainly hurt things, but I guess it depends on the time of year in terms of crops maturing and when they're actually going to begin harvesting things. Maybe being somewhat dry might be good for a harvest, but hopefully they've got enough rain for these crops to mature. Again, it's a little bit wetter than normal across the central part of our state. And then this is a look forward in time. And the CPC, the Climate Prediction Center, is looking at drought conditions basically persisting over a good portion of the western part of the United States, the Pacific coast states, as well as in the Intermountain West. And even in our area, it looks like drought removal might be likely over parts of southern Wisconsin by the time we get into later in this period. This is from September 1st to November 30th. For the next 90 days, perhaps conditions beginning to improve. Actually, next 60 days, conditions beginning to improve. Oh, not actually 90 days. Looking at hazards coming up, we're going to look at the forecast in a moment, but This is looking at week 1 and week 2 hazards. Again, this is put out by the Climate Prediction Center. And they're looking, you can see the legend down here in terms of the likelihood of tropical cyclone formation. High is in red in this striped area of white and red, at least in the Atlantic. Potential for some development off the coast of Western Africa later in the next week or so. The above average rainfall out over for the fish out here with with the track of a recent hurricane that's passed through there. And then when we look into week 2, looks like some development again off the west coast of Africa possible, and maybe something in the Gulf of Mexico during this period. Out in the Pacific, we can see dry conditions extending along the equator from just west of Central America, and then another area that's well to the southeast of Japan. But then things may be getting a little bit wetter again once we move into week 2. So we'll again begin introducing these maps. These aren't things that we've looked at typically, but we can sort of get a sense of how these hazards are developing, particularly in the tropics.
Can everyone hear him okay back there without the mic? Okay, thanks.
Thank you. Thanks for asking. And then shorter term, this is the outlook, 6 to 10 day outlook for North America. Above normal conditions in terms of temperature are likely. Just one thing, as you interpret these maps, the deeper the red does not necessarily mean it's going to be even warmer. It just means the confidence that it will be warmer is higher. And for precipitation, we can see heavy precipitation, above normal precipitation, expected from South Texas all the way up into the Northeast where they really don't need it. And maybe some relief in the Pacific Northwest over the shorter time period. Over the last 24 hours, this is the cumulative precipitation. We'll see a couple areas that we'll see also when we look at the satellite image. You can see the remnants or the last vestiges of some of these storms. Over the southern tip of Baja Peninsula, Baja California of Mexico, you can see this area of extremely heavy precipitation, over 8 inches in the last 24 hours ending this morning. That's with the remnants of, or that's with Hurricane Olaf. This area that extends from just south of Charleston, South Carolina into the western Atlantic. These are the remnants of Tropical Storm Mindy that made landfall in the Florida Panhandle earlier this week. And we see just a band of precipitation just off the east coast, the coast of New England, that was associated with a cold front that moved through our area a few days ago that gave us some pea-sized hail in some regions, and I think in the Green Bay area they had hail up to softball size. But that weather system has now moved to the east. And a lot of light precipitation. We'll kind of get a sense of what was causing that over the parts of the Ohio Valley into parts of Pennsylvania. Kind of interesting thing. And then just off the edge of this map, you can see heavy precipitation. This is the multi-radar, multi-sensor precipitation analysis that NSSL runs every day, taking all the sensor data available and coming up with a precipitation depiction. This isn't all just radar. In the next 48 hours, just looking at precipitation, some light precipitation, kind of those zones where they're already kind of wet in the northern part of our, or north of us, in the central part of our state. And you're going to watch as this area begins to blossom out in the Gulf of Mexico over the next 48 hours. And then for the week ahead, again, we're going to narrow everything down and look at the current weather conditions and the forecast. We're just giving you a hint at some things we're going to be considering. And then this is the week ahead forecast with heavy rain expected over the Gulf Coast of Louisiana and Texas. Again, this is the accumulator over the next 168 hours, 7 days. There's a track of Olaf as it moves on to the Atlantic. But a wet period there. Fortunately, some showers in the northwestern part of the United States and along the British Columbia coast here, so things getting wet at least temporarily in these regions. But the forecast is for the drought to continue for much of the next 90 days or so. We'll get to that in a moment. I'll come back to that. So, first off, if you want to come up now, that'd be great. We'll start off with the current radar. And a couple things that we'll see that are real nice are these showers that are occurring over parts of California, Oregon, and Washington State. With the weather system we'll see on the maps just in a little bit. Again, this is much needed rainfall here, but to the extent that there's any lightning in this, there's going to be a concern. It's been so dry there, any lightning strikes could also provoke additional fires. So it's the trade-off between getting some thunderstorms hopefully with lots of rain, but not with much lightning, so the showers would be preferred over thunderstorms. Off the, in eastern Canada, maritime Canada, you can see this band of precipitation here. This is indirectly related to the tropical, or Hurricane Larry, which is out in the Atlantic, and we'll see the relationship between perhaps this band of precipitation and how it extends to north of St. John's, Newfoundland, and the relationship between that and the tropical storm, or the hurricane. And then some thunderstorms in the, just off the Jacksonville, Florida coast, out into the Atlantic, and a few thunderstorms again that have developed. I don't know if that's a remnants of a nighttime sea, land breeze circulation out over the Gulf of Mexico this morning. So pretty quiet over the United States at this point. We'll go to the next link, which I think is going to be the satellite image. Oh, it's actually the surface map, which is okay. So here's our current surface map. Here at Madison with a nice light northerly wind. 72 degrees, dew point at 55, so it's really comfortable. Great outside. And again, fairly just quiet conditions over much of the United States at this point. What we're going to be watching are, we're going to see the flow over the weekend becoming more westerly, and we're going to see a dramatic increase in temperatures over us over the next couple of days or so. Here's this band of, here's the cold front. We saw some evidence of it in the 24-hour accumulated precipitation. It's pushed even further to the east with northwest winds and nice conditions over New England at this point. Let's go to the Pacific Northwest. Take a look at the map. There are conditions out there, and you can see sometimes it's, you can see radar with some precipitation, but sometimes that's just virga and things are evaporating, but you can actually see some light and in some cases moderate rain in northern parts of Oregon. So this is, again, really good for them. Nice steady rain as opposed to the convective types of precipitation. So this is really good, even if it's just temporarily alleviating the drought. You don't want a lot of it at once because since it's been so dry, you can get a lot of runoff and that can cause flooding and other issues. So pretty decent weather out there, even though it's rainy. I think they'll take the rain, given that they need it. Really quiet and really nice dew points. If we scroll down here to Texas, I believe this is either Waco or College Station right here. 84 or 59 in early to mid-September is not bad at all if you live in those areas this time of year there. And I would have loved a day like that in September. But then you get over to Florida south of this front, you can see temperatures in the 90s, upper 80s, low 90s, with dew points in the 70s. So pretty oppressive and uncomfortable there. All right, so let's go on to the next. And I think the satellite, before we do that, let's go over to right there. Excellent. Okay, so here's our satellite image, current satellite. Here are a couple of the most conspicuous features. Here is Hurricane Larry that's moving to the northeast. It's expected to make landfall in eastern Newfoundland later today. And it can pass over St. John's in the northeastern tip of Newfoundland this evening, or over the weekend. Here are the remnants of Tropical Storm Mindy that again made landfall in the Florida Panhandle, moved across Georgia, exited off the east coast, and has been traveling to the east-northeast. You can see its low-level circulation shows it really well, but you can also see that it's somewhat sheared with some convection developing on the northeast side of this disturbance. You can see the colder cloud tops kind of bubbling up here. But this circulation is not currently being watched by the Hurricane Center at present, but maybe there's some chance if the shear were to relax, it's not forecasted to, that maybe some further redevelopment of this system might be possible. We saw some showers just east of Jacksonville. You can see the showers there. It's just a little bit of convection just off of Jacksonville. And then when we get to the Gulf of Mexico, you can see that line of convection that's been pushing southward, not really organized at this point. And a broader area of showers and thunderstorms just to the east of the Yucatan Peninsula, and then just north of the Yucatan Peninsula. And it's in this area, particularly the one in the western or southwestern Caribbean, which the Hurricane Center is going to be watching over the next, over the weekend. The potential development as this moves toward the west-northwest and emerges into the southwestern or the southeastern Gulf of Mexico later this weekend. And it's this area and a surface trough that's located in this region as well. But as the development occurs, we saw in the 48-hour accumulated precipitation and over the next week, the potential for a big rain event over parts of southern Louisiana and East Texas. Yeah, great.
It's interesting that this event in the Western Gulf of Mexico has been in the long-term frogs off and on for about the last 2 weeks, or maybe even up to 3 weeks, into the longest extension of the frog. So there's something that's causing this that's predictable,
Right.
I think. And I find, that's what I find most interesting about tropical storms, is the seemingly inherent predictability out to the long term, on this time scale of many days or weeks.
Right. No, I think, Greg's point is really an excellent one, is that, 20 years ago, 25 years ago, when I first started doing Weather Watch here, looking at a 10-day forecast would have been more like looking at a cartoon, particularly in the tropics. The likelihood of a model kind of keying in on a signal of a development would have been kind of unheard of and unlikely. And it's not to say that forecasts at that length or even a little bit longer, up to 2 weeks, are significantly better, but there's increasingly evidence that there's signals that emerge in the forecast of a development out at the 10-day to 2-week time period that kind of lock in, and you actually see the development. It's not going to be exact, but it's going to give you the sense that this is a place of concern, an area that you're going to be, it's worthy of watching. Coupled with that, and the shorter range, the Tropical Prediction Center, National Hurricane Center, now do issue outlooks out to 5 days, and they can look at a wave over the central part of Africa, disturbance over the central part of Africa, and say in 5 days we think this will emerge off the coast and possibly develop 70-90% likelihood of something developing. So it's really a tribute to the use of data, the enhanced use of data that have improved our forecast and our analyses, or improved the analyses, which have led to improved forecast. And finally, this is Olaf, just off the west coast of Mexico, moving into slightly cooler waters at present. But again, big ridge over us, generally fair weather. You can see some cumuliform clouds beginning to develop in these regions, and some of these were producing rain showers yesterday. As we get into this time of year, and we'll see this at 500 millibar maps, when we get these cold pools of air aloft, that leads to some convective potential for instability in the vertical, so the static stability gets reduced, so you get allowed to get some convection going. It doesn't necessarily get particularly deep if there's any even weak subsidence occurs on top of that layer, but it's moist enough, cool enough, you're getting some convection aloft, you're getting moist enough at the surface, cool enough aloft, and with some heating, these cumuliform clouds can develop pretty quickly, and just fair weather cumulus, nothing to be too concerned with. And then again, western part of the United States, there's that weather system tracking into.
I have another thing.
Yeah.
I'd like to point out that in Florida, we have I wouldn't say real unusual, but it's a little different than normal westerly wind pattern, southwesterly. Normally the winds are easterly in Florida, and you have sea breeze fronts forming on the east coast and then moving toward the west. But today, we see the sea breeze front forming on the west coast and starting to move across the peninsula toward the east. And so that's kind of reversed from the typical summer pattern.
So it's like Atlantic convection here, kind of moving away from the coast. Yeah, so this is not quite the typical pattern. You can see the trade winds nicely across the Caribbean with the weather systems and the cloud, little cloud elements moving from east to west. But pretty quiet again over the country. Let's now look at the wind aloft. We'll start back at the 200 hectopascal. And what we'll see on this map, this is 200 hectopascal, 200 millibars up. You can see this broad ridge, this broad anticyclonic circulation out over the West Atlantic, and this really impressive jet that extends from just off from Wallops Island all the way well into northern Canada. 144 knots, pretty impressive. It's been strengthening over time. If we were to look back at the animation associated with this, we would see the development of this jet feature. And I think part of it, I'll present some evidence for this in a moment, is associated with the hurricane, which this morning was located roughly in this location right here. And the outflow from this hurricane is helping to produce a potential vorticity gradient in the upper troposphere, and that potential vorticity gradient is going to be manifest in terms of the wind field as a jet. We'll look at a cross-section through that in just a moment. But here's this trough that exists over the eastern part of the United States. We're in a nice northwesterly flow. But you can see the temperatures in this trough are, in this case, actually warmer. So we're in the lower stratosphere right here. You can see it's minus 44 degrees Celsius here. But in terms of temperatures, this is actually, you might say it's a ridge, where it's minus 52 degrees down here in West Virginia. So we're just above, if you were to again slice through this, learn about this in 452, 751, you may have already talked about it before. A positive potential vorticity anomaly exists over the southeastern Canada and the northeastern part of the United States and parts of New York State. And above that, you typically see warmer temperatures than normal. Beneath it, you see colder temperatures than normal. So we're probably in the lower stratosphere in this region. Over in the western part of the United States, downstream of this trough, we see some precipitation. Okay, that's kind of expected if we look at the curvature of the flow and how the curvature changes. We can see there's ageostrophic divergence expected typically east of the trough, so we get ascent there, and that's going to be associated with some of the precipitation that we see in this region. Same thing here with the change in curvature. East of this is where we expect to see precipitation. We saw that along the front, and a few days earlier, associated with a weak cyclone that was associated with it. So pretty quiet, again, I would say that generally quiet weather that's occurring. Let's go down to 500 millibars. We'll come back to that jet in a moment. We'll go down to 500 millibars. Now we're in the lower troposphere, and you can see clearly in red, these dashed contours in red are temperature. The black contours are the geopotential height. You can see the winds in knots. And you can see this cold pool of air that's located over western New York State and Pennsylvania. And that cold pool, again, aloft, is going to be conducive for these cumuliform clouds, these cumulus clouds developing over the course of the afternoon as the ground gets heated up. And so there's that cold pocket. Here is our tropical cyclone, Hurricane Larry, again, moving to the north-northeast. You see right here, just perhaps that's a little bit of the remnants of Mindy, and then there's Olaf down over southern tip of the Baja Peninsula. Again, this is not the most exciting map to look at least in my estimation, but you can see here a nice northwesterly flow over us, and we'll now go down to 850 hectopascal. And nicely, another thing to note, even though the contour level has changed, you see lots and lots of contours here. That warm core nature of the tropical storm, the hurricane, here gets more intense as you go lower down in the atmosphere, which is kind of typical. Again, a fair comparison would be if we did this all at the same contour level, so you can truly see that. But you can see the representation on this map looks really intense, and it is more intense in the lower troposphere than it is at upper levels. Same thing with Olaf here. And you can just basically make out a weak trough here, which is the remnants, at least in this analysis, of Mindy. The key thing that's going to be a factor in our weather coming up this weekend is, as this ridge axis moves to the east, we can see a trough moving away from the Rocky Mountains. As the flow becomes more westerly across the Rocky Mountains, you get a downsloping and a compressional warming effect. And as those winds turn to the west, with the orientation of the isotherm, we're going to get warm advection beginning to develop. So today and tomorrow are going to be warmer than they were the last couple of days. And we're going to see some extreme warmth briefly tomorrow, maybe getting into the low 90s as the winds turn really strong to the west, and we get nice warm advection from the west and southwest. So that's something we'll look at a little bit more carefully. Just for today, if we could peek, it's not on my tabs, but go to your sounding maps. Let's look at 850 millibar sounding for Green Bay from this morning. You can make it a little larger, please. So one of the nice things to do when you look at these soundings, so just to orient ourselves, the white line here is the temperature profile from the sounding. The green is the moisture profile, this is the dew point. And the dry adiabats are these red lines that extend off to the up and to the left on this particular map. One of the interesting things you can see at 0Z last night, or 12Z this morning, excuse me, is this strong inversion layer. You kind of expect that at night. You get radiational cooling overnight. Things cool off, so the ground is really cool. But above that level, you can see this nearly dry adiabatic lapse rate, kind of almost parallels the red contours right here, which is the remnants of yesterday's well-mixed layer that formed. And so if you wanted to, based on just this map, kind of get a rough estimate of what the high temperature perhaps in Green Bay would be today, is you could go to the top of this layer, assuming that we're going to get fairly breezy conditions. winds are pretty decent aloft, and it's gonna be sunny. We saw that in the satellite image. We can go up to the top of that well-mixed layer from yesterday, and even though it might be shifting a little bit to the right, bring this air diabatically down to the surface, and that gets us to about 24, 25 degrees Celsius. So we might expect the high temperature later today in Green Bay, and it could add a few degrees south here. It'll probably be in the middle to upper 70s, 75, 77. Maybe for us we'll get up to 79 or 80 in Madison. But you know, that 850 rule is often a really good one to use, just based on the fact that we have sunny conditions, breezy conditions that are going to help mix up the boundary layer. You've got a well-mixed layer. So we have this inversion that I'm not sure we're going to break through that. But at a minimum, it could perhaps get us to the upper 70s.
Except for one thing,
What's that?
it's now in September, and the sun's getting lower, and we may not be able to pull it off.
Right. So that, yeah, this is best used as a tool. Thank you, Greg, for that. This is best used as a tool during the middle of the summer as opposed to beginning to get to early fall. I think this will work out today.
Yeah, I think it's better.
I think this will work out today pretty well. You wouldn't want to use this rule in the middle of December. Not here, the middle of January, that time period. Also with snow cover, you're not going to do that. And other factors to consider are, is the ground warm, or is the ground wet? Because, you know, where is that radiation going? Is it going to evaporate liquid water, or is it going to heat the ground? Okay, let's go back from this, and let's go back to that PDF deck, please, Pete. Actually, before we do that, let's go to the Tropical Tidbits link. Over two more. Right there. Okay, so this is from the GFS this morning. This is the 6-hour forecast, which shows our Hurricane Larry located here. And you can see it's strong cyclonic circulation. Again, this is contoured every 2 hectopascals, so it looks more intense than I would say than it really is, but this is not a standard contour interval. And there's Mindy. And you can see this band of really heavy precipitation that's out to the northwest, north and northwest of this particular tropical cyclone. You can also see, when you look at the thickness contours, which are these red contours on here, they become blue once you get below 546 decameters, you can see a gradient in thickness, and this kind of outlines roughly a region where we might expect to find at the surface a frontal zone. And we're getting precipitation in the vicinity of this thermal gradient. And one of the things that I'd like to do is we're going to take a cross-section ahead of this tropical cyclone, just to get kind of an idea of the structure of this. And this also cuts through the jet, right? We see the strong baroclinicity, the strong horizontal temperature gradient. This can be manifest in the upper troposphere as a strong jet. And we're going to take a look at that. So if we go to that slide deck, please, Pete. And go to the next. Yeah, there we go. So here's from that same time period, the cross-section from A to B, as all cross-sections are drawn from A to B. This is potential vorticity in the shaded colors. The reds are really high values of air-tilt potential vorticity. Yellows are kind of moderate values, and then when you get to the blues, these are really low values of potential vorticity. And we'll see a couple things. So this is, again, ahead, there's no tropical cyclone in this cross-section, all right? But you can see as you go, maybe almost midway through the cross-section, not quite midway, is when we'll be getting to where the thickness gradient shows up. And that's also manifest in the potential temperatures that are plotted here. Those are in green. As you can see a change in the slope of these isotherms, this indicates there's a front right here, okay? We also have, coupled with that, the winds normal to this cross-section, dashed means into the cross-section, solid would be out. These are all into the cross-section. And so we have sort of a lower to middle tropospheric front, along which we're getting, if we were to plot frontogenesis, which I haven't done here, we'd expect to see a circulation with warm air rising, cold air sinking here, which is going to help to produce the precipitation if it's moist enough, but also deplete the potential vorticity in the upper troposphere out ahead of this trough that's approaching. Where we get into the upper troposphere, lower stratosphere, you can see the change in the structure of the tropopause, where we define the tropopause as being a particular PD contour, like this dashed contour right here, which is between 1.5 and 2. You can see where we have that maximum gradient, horizontal gradient potential vorticity coincides with the strongest winds going into the normal to this cross section, into the ward, into the screen, if you will. So we have lower tropospheric front, which is pretty intense, and Part of it's probably going to be associated with the circulation of this tropical cyclone, creating a frontogenetical pattern well to its north and east. That frontogenesis is going to be associated with a rising, thermally direct circulation with warm air rising, cold air sinking. That's going to help produce some of that precipitation. And I think it will also help deplete some of the potential vorticity aloft through PV redistribution. These are things we're going to be talking about in 452 and 751, and that'll help enhance the jet somewhat. If we step ahead 6 hours, moves to the northeast, I get a nice structure, image of our tropical cyclone there. As it moves, you can see really broad circulation that occurs. We're now kind of missing that front, which has moved a little bit further to the north. But you can see this extrusion of high potential vorticity down from the upper troposphere into the middle troposphere, almost lower troposphere, as a tropopause folding type structure that's occurring behind this tropical cyclone is kind of beginning to undergo a transition. So it's kind of a neat artifact of that. You can again see where the potential vorticity gradient gets strongest, the horizontal gradient along isotropic surfaces in particular. That's where you see the maximum winds normal to this cross section. It's a really nice dynamic picture of a tropical cyclone interacting with an upper trough. Yeah, great.
I think it's worth pointing out that this jet, this upper trough, is being built by the tropical cyclone. It's not just interacting with it, it's growing it.
Mm-hmm.
And if you look at the overall circulation, you can see that this jet, together with Mindy, and Mindy and Larry together are creating this fold. And I've seen this in numerical simulations a lot, that the tropopause can actually be forced to fold down, even reaching the surface, by the outflow from the tropical cyclone. It's the circulation of the tropical cyclone is creating this front. The front is not helping the tropical cyclone.
You're talking about
the front
this
is
front
the
right here.
tropical cyclone.
Right.
Yeah, it's actually forcing potential vorticity to be pushed downward into the troposphere.
Right, so the circulations are coupled, right? So I think to say that it is the tropical cyclone might be a bit of a, it depends on how you want to view it, the cause and effect part of this. And this is, again, for folks that are, students in particular that haven't participated in this before, we have these discussions about, how to describe what we're seeing on these maps. This is not, some of it's settled science, some of it, I'd argue, is worth debating and having a back and forth like Greg and I are having right here. Greg's suggesting that this extrusion of high potential vorticity air and the creation of this front, which you can see, again, these sloping isotropes, these are lines of constant potential temperature. Potential temperature is the temperature a parcel of air would have if it were expanded or compressed adiabatically to some reference state. Typically, we take it to be 1,000 hectopascals. It's the temperature that would be realized by that. But it's a nice, its gradient, its horizontal distribution is useful in identifying fronts. And so Greg is suggesting that this tropical cyclone, you can see the nice cyclonic circulation associated with it and its warm core, that the circulation of this tropical cyclone is helping to contribute to the subsidence of this high PV air, which is leading to the creation of this front. Is that a fair?
Yeah, it's basically the tropical cyclone is acting as the up branch of a quasi-geostrophic. I think there was something here before, but the tropical cyclone is enhancing the quasi-geostrophic circulation in the entrance region, which is driving the formation of the jet. Also driving the formation of that precipitation band to the north,
Right.
which is effectively what they call a predecessor rain event.
Mm-hmm.
The same thing that got New York last week from
Right.
Ida. So this is a very good cross-section, and you're actually showing the physics
Mm-hmm.
of how the tropical cyclone is creating the rain event out ahead of it.
Right. But I would say it's two parts, because when you first look at this, you might think of it as just purely being the outflow. But I think there are two parts to it. We can go back to the Tropical Tidbits webpage and go to an 850 hectopascal analysis. We'll see this. And it really focuses on the earlier time. But if we go to 850, scroll down, lower dynamics, as they call it, and go to 850, is there temperature? Or heights and winds, we can try that. If you look at this at this map, actually, do we have is there a surface map? So I go to lower dynamic. So civil pressure. Just the means level pressure. I'll go to the left again. And then first one. Increase it. That's the same map we started off with. Hold on a second, sorry. Let's do this thing. 850, lower dynamics, 850. Oh, 10 meter wind, there we go. Okay, so this shows the wind here, and what we can see in the wind field, again, it's well to the north of the tropical cyclone, but there is this inverted trough right, or this trough, this elongated area of lower pressures at the surface. So the trough, this is where the warm front lies. Right through here, you can see the shift in wind from southwesterly to east-northeast or east-northeasterly. There's a surface barochronicity here, and we cut through that in that cross-section. This extends all the way back through here to the northeast to the northwest of the tropical cyclone. And it's along that surface front, which I think is helping with the transport of moisture, water vapor, as well as heat, warmer temperatures here, helping to maintain that front. That's allowing for a thermally direct circulation with a warmer rising, colder sinking. And it's somewhat, I think, separate, Greg, from the tropical cyclone circulation is impacting this, but I'm not sure how much of the ascent here is occurring as opposed to what's going on with the front well to the northwest of the cyclone.
Well, the thermally direct circulation in the entrance region of the jet involves the upward motion. And
Right.
I think the tropical cyclone becomes that upward motion that feeds that circulation. And then, I mean, this happens with mesoscale convective systems as well. And then the sinking on the cold side, actually, if you look at the entire secondary circulation of the tropical cyclone, the overturning circulation, this is adding energy to it, because not only is the tropical cyclone releasing energy, its subsidence is in colder air.
Right.
So it's a baroclinic source of energy. You're actually lowering the center of gravity by making the cold air sink underneath.
Mm-hmm.
And so now, by incorporating this circulation into the tropical cyclone, it becomes a quasi-baroclinic system, or a hybrid baroclinic system, I should say, deriving part of its energy from the cold air sinking,
Right.
as well as the warm air rising.
Right. No, I fully agree with that aspect of it. So, again, a neat transitioning storm. This is expected, again, to undergo an extratropical transition. The Hurricane Center is looking at that over time. Track across eastern New England, and then this past just over, I guess, St. John's, Newfoundland, right about here as it moves towards southeastern Greenland later this weekend for the next 72 hours. So, yeah.
How common is it to have the PV power as strong as it is at that high latitude? I feel like I'm used to seeing it degraded more and a little bit more extratropically by the time it's that far north. Is that just because it hasn't interacted with much?
Right, so this is, as it's beginning to undergo that extratropical transition, you can see this broader circulation that's emerging. You can see fronts beginning to develop associated with the cyclone, warm front to the north, very evident cold front just to its west. I think it's because it's undergoing that transition that you're seeing this strong thing. The question was, how typical is it to see this sort of tower of potential vorticity associated with a cyclone at this latitude? And I would say, the category 2s and 3s of this sort when they get to that latitude, you can probably see that, particularly as they're about to undergo transition. Yes, sir.
Perhaps Larry's a little too far to the east-northeast, but is it what is part of the reason maybe why it's maintaining its strength over time as it moves into higher latitudes? Is it feeding off the Gulf Stream somewhat? It might be too far east or northeast, but
Maybe, there may be a contribution to that, but I think at this time, and maybe we can, Pete, if you could go quick ahead one map time and then go to the sea level pressure and thickness, the more standard map, the first one at the top of that, right? And we step ahead one more time. Yeah, the Gulf Stream, we can look at the sea surface temperature analysis, comes up and heads east. So it's probably still over relatively warm waters. And the Hurricane Center hasn't classified this as transition. But if we can click ahead one more time, you can see this cold advection just to its west. Watch what happens over time. It's clearly a warm core disturbance at this point, maximum thickness over it. It actually stays in the ridge, so it hasn't quite transitioned, but again, it's really beginning to develop more of an extratropical look to it. At this point, certainly as we have a cold convection just to its south and southwest, cold convection out ahead of it. So it's undergoing that transition at this point. Yes, sir.
Obviously, I think it's obviously less impactful, but would it be a situation similar to Sandy?
No, I don't think that's in the forecast. What aspect? Let me ask the question.
Just
I'm not
like
sure.
the undergoing the extratropical transition and the frontal.
No, the difference with Sandy is that it's not going to make that, doesn't appear it's going to make any hook back to the west as it undergoes that. But, I mean, for the places that experience it, they're going to get a lot of wind and rain with it. But, you know, Sandy did undergo a transition, so from that aspect, yeah, it'll do a transition. It'll look more extratropical. And we can look at this next week and see what actually happened. So there's some similarities with those transitions. You go from this warm core disturbance to something that's either a hybrid or fully developed fronts, warm and cold fronts, and you see the temperature convections with it. And as Greg was saying, as that transition occurs, the energetics change from an air-sea interaction to one in which you're getting a conversion of available potential energy as manifest by the temperature gradients to kinetic energy of the storm. Okay, so finally, I'm going to get out of the tropics and we'll go to the last tab. And we'll start off with just the current, this is the surface map at this point, which we saw earlier, and we'll go ahead, just in the interest of time, to 18 hours of the forecast, so 1 a.m. this morning, the morning coming up. Okay, so here in Wisconsin, again, those westerly winds, the warm advection is continuing over us, the thickness is beginning to increase, but dry conditions over us. And it's a pretty quiet pattern. The rain showers and the precipitation is all over the Pacific Northwest, moving into Idaho and southern Alberta and western Montana. Okay, let's go ahead another 12 hours, 24 hours, yeah, 30 hours is good. You can see that structure, the isotopes, our thicknesses have gone from the low 570s to over 576 with strong warm advection at this point. Again, you can see this sort of plume, strong, positive temperature advection across the upper Midwest. We can also, we'll come back if we have time, look at the actual temperature advection as diagnosed in this analysis. But let's go ahead to 30, let's go to 42 hours. Okay, so this is 1 a.m. on Sunday morning. And by this time, if you look at this, you can see the minimum in sea level pressure, that trough that extends ahead of this cyclone that's well over the Central Plains. It's just about on top of us at this point. And so that's when we're going to perhaps begin to see a wind shift and cooler conditions beginning to move into the north. Again, the precipitation forecast is there's not much precipitation that's forecast for us, but the warm advection is pretty much over by this time. So the significant warm advection is going to be well to our south. If we could, as we focus on this, switch from continental U.S. to region, look at the upper Midwest, just to zoom in on what's happening here. Not that one, please. Yeah, please. And to see that, let's go to temperature. Oh, sorry, temperature. I'm not sure if people in the back can see this that well, but you can see, if you can see this, you'll see over parts of northern Illinois and southern Wisconsin, southerly winds, southwesterly winds, and pretty much right through Dane County, you can see there's a wind shift to the north. We have northeasterly winds, so that's that front that's going to be just on top of us. If we step forward in time in 3-hour increments, with the 9Z map, you can see those northeast winds show up pretty nicely. It's the cold advection started just over us. As this temperature gradient's beginning to intensify. Go ahead again. Again. The temperatures to our south don't really change much. So we're going to have a really strong temperature gradient front developing over us, but there's not much in the way of, there's a lot of heating here, and presumably a lot of clouds over us, so we're going to get this sort of diabatically generated front, or thermal gradient, but I don't see much in the way of a strong frontogenesis at the moment. Frontogenesis through kinematic frontogenesis over us is going to be probably due to cloud cover to the north and some sun to the south. We can actually check out the cloud cover. This is 15Z, so Sunday morning. So it works. So there's the sun we need to heat the ground out to our south. So we're gonna be a pretty cloudy day on Sunday if this particular forecast were to verify. Let's go ahead to 60 hours. And we'll switch back to that surface map. And clouds overspreading the entire area. And down one more right there. A few rain showers to our north, but the basic, that front is gonna be just to our south. So looks like tomorrow is gonna be the warmer of the 2 days that we're gonna be experiencing, that we're gonna, over the 2 weekend days, with tomorrow probably getting, we'll see close to 90. We'll get the Moss numbers in just a second. Close to 90, but I would say a little bit cooler on Sunday. This is the 0Z's Monday, which will be Sunday at 7 p.m. Past sunsets, we've already started to cool off at this point. Let's go ahead to 72 hours to Monday morning. And this baroclinicity, because you don't see much of the front at this level, but clouds and showers to our north, and we can just go ahead a couple more clicks. Let's go to 96 hours, just go a day ahead. Basically stay in a relatively warm pattern with this front just near us with the possibility of running out of energy or of some light showers over the southern Wisconsin early next week. One thing I do want to do comes back to what Greg was saying about tropical cyclones in the really long-term forecast, is just explore one last thing that's kind of interesting. So we'll go back to the U.S. map, North American map, national. And we will go to Wednesday, 12Z forecast. And we're going to go to 360 hours. Hope I got this right. That's Wednesday, 12Z. Let's go to Wednesday, 18Z. That forecast. Sorry, go to Tuesday. 18th. You guys are gonna think I'm crazy. Hold on. I know it's there. All right, this isn't working. Let's go to 0Z 60 forecast from last night. Out at 360 hours or so. Okay, so here is an example of a really long-term forecast. This is 360. We're looking at forecast initialized 6Z this morning, verifying 15 days from now. So you could, 14, 15 days from now, you might say, what's this have to do with anything? Well, it's a nice forecast, one, because you can see professionally cooler air coming into us, but here's this tropical cyclone that's out over the Bahamas. If we go back to the 0Z forecast, initialized last night, so 6 hours earlier, nothing really shows up there. There's a cyclone out here east of New England, but big whoop, there's not much that's going on there. Let's go back another 6 hours in the forecast. Nothing shows up there. Notice how these are all verifying at the same time, by the way, or similar times. Go back a little bit earlier. That's what I was looking for. There we go. So this is not to say this is going to happen, but there is already beginning to emerge a signal in the forecast that some sort of disturbance is going to develop in the Bahamas, east of Florida, and the potential for a landfalling tropical cyclone. Now this is, Greg and I were just talking at the beginning of Weather Watch, near the beginning of Weather Watch, about how these forecasts, these long-range or medium-range forecasts, kind of give us hints at something perhaps developing. If we actually take this particular forecast, let's go back one more time, we'll come back to this forecast. You'll note, a forecast initialized 6 hours earlier, nothing. So what's going on here? So let's go back to that forecast. I'll show you something that's kind of odd. You might say, oh, this might be one of these Cape Verde storms that comes all the way off the coast of Africa and impacts us. If we just go back in time, we can just use this to look at the origins of this. You can see it's a pretty intense storm as it moves through the Bahamas. 9:59, we're going backwards in this particular forecast time. 9:54, 9:54, pretty nasty looking storm. As we go back and look at how did it originate? You'll see it's been just sitting down there. This is now the 21st, 6Z. You can get going back. It's just broad area of disturbed weather, something else in the western Gulf, but not looking at that. But this just emerges not from something that apparently was traveling from the east, it just sort of kind of almost develops in place, which is just really interesting feature. And this, again, something to watch the next couple of weather, we have at least one weather watch, 2 weather watches that we can go before this actually may occur, if it occurs at all. But just this broad area of disturbed weather, you know, north of Cuba, in the south central Bahamas, just begins to develop.
Is that signal in other forecasts, like that initial and the slight variation doesn't intensify in other forecasts? Can we look at that?
Right,
different
so,
ones?
yeah, so let's look at, let's go 6 hours before. Something like this, I don't know if that's the same disturbance. So this is when it gets a little bit tricky. Are we looking at the same disturbance? We go ahead 12 hours from that feed. Is this it? I don't know. So, just something curious, but it's an interesting question, is how, you know, what are the signals that we're seeing? What's leading to the development of this, in this particular model run, this universe, if you will, this, you know, we have a multiverse of solutions. What's the one that's actually going to occur? I don't think this is, you know, nothing that's substantial yet, but if we get a couple more runs that are doing this, we might begin to, you know, ask the question, what are the origins of that additional disturbance? What is the model keying in on? And then just something for us to watch, and weather watch in the next week or so. Does it show up again? Does it continue to show up? How soon do we get a signal that's reliable? So just an interesting question to consider forecast. Anyway, so just to kind of reiterate for the weekend, really warm tomorrow, probably getting into the upper 80s to low 90s. We can go bring up a weather program and look at the model output statistics for Madison. A couple days ago, they're going 90 to 92. And we'll get that text a little bit larger. Sorry, Pete. For those of you in 452, 751, here's our weather program. Slash new MR, new ADN. Yep. And then MSN will last. Bring this up. So this is, you're not taking the explicit output from the model, the raw output from the model, but doing a statistical post-processing of the output. This is guidance that forecasters use to come up with estimates for the forecast for the next couple of days. You know, this is forecasting a low tonight here in Madison at the airport of 60, high tomorrow of 89 degrees, and then low Sunday night of 66, and then a high of 82 on Sunday, and cooling off as we get to Monday, maybe with some rain. This is the probability of precipitation in 6-hour increments. We can also see the shift in winds. We have those southerly winds during the day tomorrow, shifting and going south, and then they flip over by Saturday evening to the northeast. And that's when we begin to cool off a bit, and then we'll recover after that. So, overcast skies. I'm going to guess that Sunday's probably going to not get into the 80s, but it's going to be cooler than that with the cloud cover and the northeast wind. But that's the, and again, slight chance of precipitation to get later in the period. And if we do get precipitation, the most likely type will be rain. That's no surprise here. Sometimes we see snow down there, but not yet. Not yet. All right, well, that's it for today. Thank you for your attention, questions, and comments. Look forward to seeing you next week. We'll send an email out if there's any slight change in the time that we're meeting. We'll make sure it's open for everyone to come. Have a great weekend. Stay safe, stay well.
For my class, we'll meet in, we'll meet at 20 after, but just take a break. We've got 20 minutes. So.